All right, you guys, 3.3, the notes for rate of change. And hopefully you've been able to walk yourself through this, but I just want to have a video in case you need a little more help. And so what's really cool is that these notes are to give you the formulas that you might need, right? Up here. I have a new computer and kind of a new setup here, so I'm not sure where my highlight button is, but let's see how this goes. Explain what slope is. I personally would say, obviously, it's the rise over the run. It is delta y, which stands for change in y, over delta x, which stands for change in x. The slope is above. There. Write equation for the line with slope of 2/3 and y-intercept is 0, -5. So easy enough using the point slope form. Y equals 2/3 x minus 5. Find an equation through the points 3, 5, and 0, 7. Well, we already have the y-intercept, so we just need to find the slope. So let's say 7 minus 5, just using the slope formula, over 0 minus 3. And this time we get negative 2/3, right? Let's see. On the numerator, we get 2. On the denominator, we get negative 3. Regardless of if it's with the numerator or the denominator, if only one of those has a negative, that means the whole fraction, we pull that negative out, the whole fraction is negative. So this one is going to be y equals negative 2/3 x plus 7. Okay, so those are going to be perpendicular lines. Not perpendicular lines. They're just going to have the same slope, and one's going to be positive, one's going to be negative. If they were perpendicular, this one would be -3/2. Okay. What is the relationship among graphs of lines with the equation y equals mx plus 2, where m is any real number? So anything, that just means they're all going to start at the same point, right? At y equals here. So they're all going to be straight lines, and they're all going to cross. I guess we say starting value when we're talking about kind of real world situations, but in this situation, it'd just be where they cross the y-intercept. And down here, what is the relationship among graphs with the equation y equals 2x plus b, where b could be anything here? These are all going to be parallel lines. If they all have a slope of 2, they're all going to be parallel, but they could go through any other points there. They just have the same slope. And next we have finding the average rate of change, which we talked about. Read through there if you're a little bit unclear. You'll notice right here, it talks about delta y and delta x, which is the change in y over the change in x. Here they're using function notation instead of y, which is why they're calling this the output. And then it wants us to use that over here. So sorry, you guys. How do I find, cool. Sorry, again, new computer, new setup, learning how to use it. So let's look at this first one. For the interval of 2 to 5 of the equation f of x equals 2x squared minus 9. So between 2 and 5 on the x-axis, if 2 is my input, my output should be 2 squared is 4, 4 times 2 is 8, minus 9, -1. Check my mental math. I should get 2 points there. And then 5, if my input is 5, I get 25. 5 squared is 25 times 2 is 50, minus 9 is 41. So I have 2 points. As long as I have 2 points, I can find slope, right? So I'm going to have, I'm going to switch these up, and I'm going to say this is my y, this is my y2, my x1, and my y1, my x1, x2. God, x2, y2, so 41 minus -1 is the same as +1 over 5 minus 2. So I get 42 divided by 3 So the rate of change between 2 and 5 for 2x squared minus 9, the average rate of change, sorry guys, the average rate of change for this is, and I think 3 can go in there, 16 times. Nope, 14 times. Just checking my mental math. 3 can go into 4 once, with the remainder 1, 12 is 4. So that's the average rate of change on the interval between 2 and 5. Okay, so now we need to do it using B, which seems weird, right? But we just do it the same way. F of 4 is equal to 2 times 16 minus 9, which is 32 minus 9, which should give us 23, double check me. And f of b, which is 2 times b squared minus 9, which we're just going to leave as 2b squared minus 9. So what that's going to look like is 2b squared minus 9 is my y2 minus my y1 is 23, my first output. My second output minus my first output divided by my second input minus my first input. And then it's just a matter of, do we need to simplify this? Well, we can. The numerator could be 2b squared minus 9 minus 23. So if I add those, I get negative 32 on the numerator over, and then on the denominator, I just have b minus 4. And I really don't see an easy way. I mean, I guess I could factor out a 2 from the numerator, but it's really not going to help me cancel anything out. So in this case, I'm just going to leave it the way it is. Here, it'll get a little more interesting with this next one. So this next one, so if we finish this, oh, close. So if we finish the very first video with my new computer, I guess I have 2 weeks to decide if I like it. I could take it back, but it's pretty cool. Okay, so now for the last one, my first input is going to be 3. My second input is even stranger than just a variable. It's going to be its own little function here, 3 plus h. So this is why we did all that work with functions earlier. So f of 3 is going to be 2 times 9 minus 9, which should just be 9. And my second one, this is the one that's going to be a little stranger. It's going to be 2 times 3 plus h squared minus 9. Okay, so what does that look like? That looks like my second output on the numerator, which is, whoops. And I'm going to actually, so 3 plus h squared is really 3 plus h times 3 plus h, right? You're going to have to FOIL that or do an area model. So I'm just going to say, now I have 2 times, if I can do this in my head, 9 plus 2h, whoops, plus 6h, 9 plus 6h, plus h squared minus 9, and then minus 9 again, because this is my first output, and this whole thing I wrote was my second output, over, then my first input was, or my second, 3 plus h minus my first input, which was 3. So the denominator works out really well. Like it just works out as h, right? Because I have 3 minus 3. So those cancel. Let's see what happens in my numerator. I'm going to distribute this 2 all the way through. So I'm going to have 18, I'll erase this in a second, plus 12h plus 2h squared minus 18. So that's cool because these two 18s are going to cancel. So now my numerator is 2h squared plus 12h all over h, and this h is going to cancel. Oh, this is pretty cool, you guys. This is like a puzzle. So if I take out an h on the numerator, you can actually take out more, but if I just take out an h, it'll cancel with the denominator. So I get h times 2h plus 12 all over h. Now you can see that these h is square. So my average rate of change between 3 and 3 plus h is 2h plus 12. Okay? And the reason why we're doing this is in calculus it becomes really important to find that average rate of change of a single point. And this is the way you do this, because if you don't add a little something to a single point, what happens is you get 0 on the denominator and it doesn't exist. So that's why we're learning how to do it by adding just the smallest amount, just the smallest interval of h on that to get those. Okay? So using the graph, estimate the average rate of change from x is equal to 1 to x is equal to 5. So we have 2 points, 1, 5, and now I look at 5, which goes to 7, 5, 7. So 7 minus 5, my numerator is going to be 2. 5 minus 1, my denominator is going to be 4. So we just get 1/2. So that was a lot easier than question 1. All right, what minutes am I at? Can I keep going? I'm going to stop here for this particular one because I'm not sure how many minutes I have on this video, but I will start again.